So in this WeDo problem, we've got 50 grams of aluminum. We have a specific heat capacity of 0.9 joules per gram degree Celsius and a temperature of 85 degrees Celsius. We place that aluminum in 100 grams of water. Specific heat capacity of water is quite a bit higher, 4.184 joules per gram degree Celsius, but the temperature is also starting out lower at 25 degrees Celsius. The final temperature is 30.8 degrees Celsius. So we've got two qualitative questions here. What can be said about the temperature changes for each substance, and what is true of the amount of thermal energy exchanged? So let's go ahead and tackle this first question. Let's see, for aluminum versus water. Our initial temperature of aluminum, we said, was 85 degrees Celsius. And for water, our initial temperature, we said, was 25 degrees Celsius. So after they reach equilibrium, we have a final temperature for both substances of 30.8 degrees Celsius. So there's really probably two things we can say about aluminum and water here. So first of all, what can be said about the temperature changes? Well, we can say that the temperature change for aluminum decreases, right? So the delta T for aluminum decreases, while the change in temperature for water increases. One of the things you might notice, though, is the degree of change. We can see that the degree of change for aluminum is a lot greater than the degree of change for the water. And we'll definitely talk about this later. So the change in temperature for aluminum seems to be a lot greater than the change in temperature for the H2O. Now, the second part of this question says, what is true of the amount of thermal energy exchanged? Well, remember, the first law of thermodynamics says that the energy lost, in this case by the aluminum, has to be equal to the energy gained by the water. So I guess we can say, let's see, energy lost by the aluminum is equal to the energy gained by the water. They have equal magnitude, but opposite sign. So since aluminum is losing energy, everything that's happening with that is exothermic. It's slowing down, its temperature is going down, its kinetic energy is going down, but water is picking up that energy. So that's endothermic for water. Water is picking up that energy, its temperature is going up, its kinetic energy is going up.